So today is the days 5 through 7 recap. So on day 5, we learned how to find permutations with identical items. Day 6, we learned how to find combinations. 7, we worked on differentiating between the two to know if we were given a problem to decipher whether we're going to use permutation or a combination to solve it. So here's some review from day 5, permutations with identical items. It says, how many different ways can you arrange the letters in the word committee? First of all, remember our first step is that you'd count up the total letters. 3, 4, 5, 6. So we have 9 letters, so that's 9 factorial, the numerator, because it's the total letters, divided by the number of repeats. So we have, how many m's do we have? 2. So we have 2 factorial for the m's. The t's, we have 2 of those, another 2 factorial because there's 2. And our only other repeat letter we have is e, so times 2 factorial for the 3's. So then we're left with 9 factorial over 8. And that equals, if you type it into your calculator, 45,360. That is a lot of different ways to arrange those letters. Wow. Now in part B, it's saying Sally decides that she's going to plant a row of flowers in her garden. She has 5 total flowers, 2 yellow daffodils, and 3 pink tulips. How many different ways can she arrange them in a row? So this is very similar to the one we just did. So we're going to want to count up our total. So our total is 5. So we have 5 factorial on the numerator. In the bottom, we have 2 yellow daffodils. So we have those 2 factorial for the yellow daffodils. And then we have pink tulips. So I'm going to use 2 or 3 factorial for different ways to arrange those 3 pink tulips. And then once you've solved that, you get 5 times 4 times 3 times 2 times 1 over 2 times 1. And then we'll cancel out what we have repeats of, because they would cancel out, and then we're left with 20 over 2, which is just 10. So that's a recap from day 5, permutations with identical items. Now with combinations, you can evaluate this with a calculator. So we're going to set it up, if you're not using a calculator, you're going to set it up as 7 factorial, because that's n, over 3 factorial times 7 minus 3 factorial. And that's going to equal 7 factorial. So 7 minus 3 is 4. So we're going to write the first 4 digits. And then after you solve that through, 35 if you type that into your calculator. And we have one more, so we're going to set it up as 10 factorial, because that's our n, or 7 factorial times 10 minus 7 factorial. And that's just going to equal 120 after you solve that through. Now last but not least, it says a hockey coach is selecting 6 starting positions from a group of 12 players. And this is assuming any player would play any position. So that order does not matter. Remember, our order with combinations, order does not matter. So we'll have 12 factorial, because that's our total here. And then, well, our n is 12. R equals 6, because that's how many we're choosing. So we have 6 factorial times 12 minus 6 factorial. And that's going to equal 924 after you plug it all into your calculator. Again, day 7 review, determining between the two. Remember, order matters with permutations. Order does not matter with combinations. And these are going to be like your president type problems, permutation, president, like different, if they have different positions, then that's permutation. But if it's committee, like they all hold the same position, like one position is not different from the other, then committee, combination. Now we'll just get some practice. We're not going to solve that. We're just going to determine if it's one or the other right now. Again, if they're lining up in a straight line, we know that order is going to matter. Since order matters, we know it's permutation. For B, we have to figure out if order matters for this one. Mr. Feig is picking 4 students from first hour to help him out. Does order matter? Let's see. It does not because they're all doing the same thing, so we know that's combination. And then for part C, choosing first and second place. Oh, different positions. So we already know that's a permutation because order matters. Now for part D, we're choosing 3 out of 5 candy bars to buy at the checkout line. Again, I feel I use the reference back to if you're picking a Twix and picking a Reese's and then picking a Snickers bar. That's no different from picking a Reese's, Snickers bar, and a Twix. So we know the order does not matter, so that's combination. And then for part E, we're picking the top 2 horses. So again, our order does not matter, even though it says top 2 horses. With those 2 horses you pick, one is not different from the other as far as order. So we know order does not matter. So no, that's combination. Part F, choosing a treasurer, a manager for a baseball team with 9 players. Again, treasurer and manager are 2 different positions. We know the order does matter, so that is a permutation. And last but not least, if you're selecting 2 co-captains for a baseball team with 9 players. Okay, think co-captains, meaning they're going to hold the same position. So we know they're not different, so order does not matter. So we know that is a combination. And again, just know on your quiz, you will need to know how you're going to be asked problems just like these. And you're going to have to solve how many different ways you can arrange them and determine if it's permutation or a combination. But there is a review assignment as well that you will either take a picture of and scan it, or scan it to me and upload or email. And then also there is a review assignment for the whole quiz, not this. The review assignment I just talked about was just for these last couple days in the week, but your quiz coming up will be on that first week of online school and the second week. So if you have any questions, feel free to ask.